All right, guys, today we're looking at a 2009 Chevrolet Cobalt with no AC. And it's not an obvious problem, so I thought I would share it with you because it's also a simple problem. This is a unit that doesn't have any obvious signs of dye leaks and holds a vacuum. And when you have a situation like that, it's usually something simple like the service ports. And so what we're going to do is we're going to go confirm that theory. We're going to use our electronic detector. This is a Master Cool Intella-Sense 2. And what a device like this does is it's able to sniff the air and detect if you have refrigerant leaking. So this is a handy tool to have if you don't have dye in the system or in a situation like this where we want to see if it's leaking out of a port. So we're just going to wait a moment for this guy to complete its self-test, and then we're going to go check the high side port first, and then we're going to check the low side port, and we're going to see if that's the source of our leak. So what she's going to do is she's going to count down these LEDs, and then she's going to start chirping to let us know that she's ready to go here. All right, we're ready to go. Let's check out the high side port first. I'm just going to position the detector of this guy kind of right by the port as we take it off the cap. Right, so we don't have anything here. Well, yeah, we do. So we have a little bit of refrigerant leaking out of here just when we first took the cap off. That's a very slow leak on the high side. Let's see what we see on the low side. That one's on tight. Tight, tight, tight. I hadn't even got the cap off, guys. And she's reacting on that side, too. All right, so the problem we've got on this vehicle is both of the service port valves are shot. This is typically a problem you'd see when you've got something, this is a vehicle that sits a lot and doesn't get driven a lot. And when you put your gauges and your vacuum pump up on these two ports, the gauge set's going to seal these off. And so it's going to look like it's holding vacuum, but it's not. So we're going to go evacuate the system. There's probably no refrigerant in it, but we're going to evacuate it anyway just in case, you know, the whole Captain Planet deal with the EPA. And then we're going to recharge it, and I'll show you both of those. All right, guys, we're just vacuuming out any atmospheric moisture that might be present in our recovery machine's lines. Pulling a steady vacuum at the moment. We're just going to do this for a few more minutes, and then we'll actually start the recovery procedure. All right, guys, we've got our high and low side couplers connected, and we've got almost virtually no refrigerant left in this system at all. It's just slowly leaked out over time. So we got our low in here, and we've got our high over here. So we're going to go ahead and start the recovery procedure. All right, guys, we've started the recovery procedure. And actually, as soon as I turned the camera on, it stopped. So there wasn't a lot in there for it to recover. Let's see how much it got. Yeah, she's empty. All right, so we'll go ahead and get everything disconnected. Let's get into changing these valves out. All right, guys, we are pulling another vacuum. Now we're pulling a vacuum on the actual automotive system itself. We also want to take note here that our moisture detector's blue. We didn't have any moisture in the little bit of refrigerant that we were able to pull. So we'll let this guy go for about 30 minutes or so, and then we'll swap out those service valves. All right, guys, things have sat long enough, so let's go ahead and close off and remove our couplers. Get our high side first. And then we're going to do the same thing over here with the low side. Going to block your view for a moment because it's kind of cramped here to do the twisty. All right. Now we're going to go after the high side first. On the high side, GM uses a special shaped tool. And this is a Master Cool version of that tool. It's just a special socket that's got, I believe, 8 sides to it. It's a 98-234 Master Cool tool. I'll put a link in the description for this. And this is what you would use with a 3/8" drive to get this off. Now, sometimes they come right off, and other times, when they're on tight, you'll have to put a wrench on this fitting that's molded into the aluminum hardline, and that's what we're going to have to do on this one because I could tell the line was flexing as I try to get it off. So let me grab a wrench and we'll pick it up. All right, guys, so this is a 15 on that cast-in piece right there. All right, there we go. Now you're going to hear a big hiss from the vacuum when you first get this guy pulled. Right there he went. And there is our defective ball valve. So this type of valve from GM has a ball seat in it rather than a Schrader. We're going to replace that with the same kind of part. This is an AC Delco 155438 or a GM 524 58184. It'll come with the new O-ring on it already. Just going to get our wrench over here again and snug it up. Put our 15 on the line so we don't put any stress on it. And just snug it up. There's no specific torque value on this one. All right, now we're going to go after the low side. All right, guys, on the low side, it's got a little yellow piece of, a little white piece of paper towel here to show you. So you can see just a tiny bit of dye all the way in the snout of this. Just another indicator that that valve is leaking. All right, we're going to use a tool like this to remove that Schrader valve. I'll block your view for just a second to break the torque. And then we're going to work it out. It's just super cramped in here, and the engine's hot, hot, hot. Now, sometimes you can get this thing to be loosened up, and she just won't come out on her own, so we might have to go grab a magnet. There she goes. All right, and there is our leaky valve. And we're going to replace that with this guy that we're cutting up here. So this definitely looks the same. You can see the, put on the white here, maybe it'll help. You can see the damage on the black seal. Got a few tears in it, which is probably why it was given out. Our replacement is an AC Delco 15-1119 or GM 304 1827. So you want to open it up away from the valve so you don't put any stress on it. And we're going to come in here with our right hand. We're going to come in here with our tool and snug it up. Might have to block your view for just a moment here. But if you've got the little shank on that, which is, if we take a look at the one we pulled out, there's a little shank at the top. That is what the tool is grabbing. Just turn it in until it's snug. You don't want to over tighten it. Just 2-finger tight, like that. So what you're doing is it's got a hole in here, so the depression valve fits there, and then it sits right there in the tool just like so. All right, so now with those replaced, we're going to go ahead, pull another vacuum to get the atmosphere that we let in, changing these two valves out, and then we'll proceed with a recharge. All right, guys, also looking in the service manual for the Cobalt and the G5, we don't find any information on replacing the high side port, but we do find information on replacing the low side port, so I thought I would show you that here as well. Just for the fact that if you have the right tool, they tell you the torque value on that one, 22 inch-pounds. Nothing on the high side, because I believe back in the day when these manuals came out, the dealer would have been told just to replace the entire hose. But anyway, there's that. All right, guys, we're almost done with this repair. We've switched over to our charging equipment, and we've got our couplers reconnected for that. You can probably hear the vacuum pump going in the background. We're re-pulling a vacuum on both sides here while we get ready to recharge it. All right, guys, we've let this sit for a whopping 45 minutes, and we're still holding 30 inches of mercury on the vacuum on both the high and the low side. Of course, the high side gauges aren't calibrated, but we can use the low side calibration to tell. So we are good. This is kind of like where this project started, where there were no leaks evident, but the leaks were hidden in the service ports underneath our couplers. So now that we've swapped them both out, we should be good to go to recharge this guy. The second thing you want to locate is somewhere on the vehicle there's going to be a sticker that will tell you what the charge is. On these Cobalts and G5s from Pontiac, it's going to be located right here, which it says system charge 0.41 kilograms or 0.9 pounds. So that's telling us how much that we're going to put in. So let's get started charging her up. All right, guys, now we're going to turn our valve off on our vacuum line. That'll hold the vacuum on the whole system, except for this teeny little bit here inside when we couple it up here. And then what we've got here is we've got a virgin Freon 134 tank here. You can't reuse what you recover. The recovery machine is not used for charging. It's only used to pull the old out. So we're going to get this guy coupled up there. We're going to come over here and we're going to tear out our scale so that it's zeroed. Actually, our cable's touching it, so you want to get it to where you don't have any flex in the hoses causing you to read anything other than 0. And then once you account for that and you're at 0, then what we can do is we can open this, and then we're going to set it to pounds, and we're going to let it go in to 0.9 pounds. I'm going to charge it through the low side. Because I'm charging it through the low side, I'm going to come up here and I'm going to close our high side valve. So we're only going to leave our low side open. And then we're going to come up here and we're going to open up our refrigerant. Now this scale is going to bounce around as you push down on it, right? So after you get it going, you want to get your hand off of it so that you got it open. And then we're going to open this valve and it's going to flow. Now, it's only going to flow so far. We're going to start the engine. We're going to let the compressor pull it in the rest of the way, but the vacuum will pull in a portion of it. So you can hear some of it going in right there. So we're going to be able to pull in probably 0.2 or 0.3, not doing anything at all. At this point, we're going to go inside the vehicle and start the engine and pull it the rest of the way. All right, guys, now we've got the engine on. The compressor is going to kick in now. There's enough refrigerant to activate it. You can see we're at 0.450. Now we're at a half. And we're just going to go to 0.9, and then we'll have her fully charged. Now, I'm not necessarily going to have you watch this whole thing. I'm not sure how fast it's going to go. It's a hot day, but we've got the tank here in the shade, so the more sunlight that hits the tank, the faster it goes. But she's going at a pretty good clip here. We're already coming up on 0.7. So we just have 0.2 more pounds to go. Now, because of the nature of this leaking through the service ports, we don't have to worry about adding any dye or adding any PAG oil. All we lost was the actual coolant. All right, so the cooling fan just kicked on the engine, and we're going to need to jump down here and shut this off. So as soon as you hit that 0.9, I let it go a little bit more because we're going to lose just a hair when we disconnect the couplers. And at that point, we're done. We shut off our valve, shut off those valves, and then we're going to come over here and take a look at our gauges. Make sure we're still closed on high, open on low. We're sitting around 200 on the high side, about 44 on the low. All right, guys, so we're going to consult the service manual, 2009 A car, right, Cobalt and G5. And we're going to the AC section. And if you've lost that sticker in your vehicle, the service manual will again tell you the refrigerant charge is 0.41 kilograms or 0.9 pounds. But what we're mostly in here to do is see about the pressures on the gauge. And so they've got this system pressure classification where, based on where your highs and lows fall, they can give you different kinds of diagnoses. It's unfortunate the service manual only shows kilopascals for the high side. They have kPa and PSI for the low side. Most all the gauges are in PSI, but they tell you in the table the PSI values, which works for us, right? And so we come over here in the performance table. At the time we were running the test, it was 91 degrees outside, according to weather.com for my area. And the humidity is probably floating somewhere between high 40s and low 50s. So we kind of combine these two values as far as relative humidity. And what it's saying is the low side service port pressure should have been sitting between 36 and 52 psi for that humidity value, 39 or 58 for that humidity value. And we can kind of compare with what we saw in the video clip for our low side. And then our high side should have been reading 244 to 296 psi or 251 to 306. And again, it's very important what the humidity is for what these pressures read, as well as what the outside ambient temperature is. So just putting this in here, taking a look at the gauges, looking in the service manual for information like this, gives us an idea about whether things are operating correctly. Now, that table that's in here, those values would fall in either A, B, C, or D, with A being okay, right? So A is relatively okay zone, but there are some things they still want you to check even there. Now, we're not going to go through all this, right? I'll run all this stuff off camera because it's time-consuming just to validate. But just to show you the kind of information that's in here, the most important part of this is this performance table. There's some colder temperature values down here that I'll just get in the screen for when people are checking this kind of stuff in the fall. But here in the dead of summer right now, in the southeast of the U.S., this is kind of like the range we're in. I'd hate to be wherever it's getting up into these kind of temperatures, maybe out west in Arizona or Death Valley, or maybe Saudi Arabia. Who knows? All right, let's keep going. All right, guys, it's currently 91 degrees outside, and we are getting just around 40 in the cabin. So I think we've got this puppy fixed, and I hope this helps you guys out in fixing yours. If you got questions or comments, go ahead and leave them below. I'll try to help. There's links in the description for the parts and the tools that we used in this video. And if you had this save you some money or it saved you some time, please hit that like button. I'd really appreciate it. And as always, thanks for watching.